Hello, students, you're welcome. Today, we want to work on these questions, the dimension of permittivity of free space and elastic constant. Now, the permittivity of free space, this permittivity of free space is coming from Coulomb's law, okay? Now, and we know that Coulomb's law states that the force of attraction between two bodies of charges, let's say Q1 and Q2, is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. That's to say that force, Coulomb's law is saying that force is directly proportional to Q1, Q2, okay? Then, and inversely proportional to the distance, to the square of their distances. This R here is the distance. Now, if I remove this sign of proportionality, I will have that my F will be equals to K, okay? K Q1, Q2 all over R squared. But we have that our K, the value of our K is what? 1 over 4 pi epsilon naught. When we substitute it here now, we have that our F will be equals to what? Yeah? 1 over 4 pi epsilon naught, then Q1, Q multiplied by Q1, Q2 all over R squared. So if we do the normal thing, multiplication, we are going to have Q1, Q2 all over. This times this is equals to what? 4 pi epsilon naught R squared. Okay, so what are we looking for now? We are looking for epsilon naught, so we can possibly cross multiply. Carry this here, bring this one down. That's all. Just carry this in, or if you don't know how to do it that way, just carry it like this. This times this will give us 4 pi epsilon naught R square of F is equals to Q1, Q2. So this is elementary way of doing it. Anyway, we are looking for this now. We divide both sides by the coefficient of epsilon naught, which is this and this, which means epsilon naught now will be equals to Q1, Q2 all over 4 pi R square. Actually, the same thing we're supposed to do here. Having gotten this, we now note that 4 pi, okay, are what? They are constant. So in working dimension, in solving dimension, we don't use constant to work on kind, except if it is on a power. Like this 2 square. Please don't say I don't use constant, you remove 2. 2 here is not a constant, 2 here is a power. Okay, but the coefficient of epsilon naught here is 4 pi. Pi is a constant, 4 is also a constant. So we don't need it anymore. So because of that, we are now going to have that our epsilon naught will be equals to what? Q1, Q2 all over what? 4 pi epsilon naught. Well, sorry, 4 pi R square. Oh my God. Okay, haven't done that. What next do we do? What am I doing? Oh, sorry. So it will be, since 4 pi is not needed, it will be R square of F. Oh, thank you. Please, let's work together. Now, we are going to substitute all these things with their what? Respective units. So epsilon naught will be equals to, what is the unit of charge here? The unit of charge, okay, or what is the formula for charge? This charge represents what? Like from current electricity, we recall that current is charge per unit time, which implies that charge is equals to IT, right? So we now take this to replace this thing. So epsilon naught will now be equals to IT multiplied by IT all over, yes, R square F. Okay. Now, we now know that this will be epsilon naught will be I square T square over R square F. So what is I square? The unit of I is, or current is ampere. So epsilon naught will be equals to ampere square, right? Then what is this? Time. The unit of time is seconds, second square, all over. What is this? Meter. Remember this is radius, which is the unit is meter, meter square. Then what is the unit of F as force? Kilogram meter per second square. Okay. Haven't done that. What next remain? we are to carry all these people. All these people are the denominator. Take it up. So we have that epsilon naught will be equals to a square multiplied by s square. So when this one go up, you have m minus 2. When this one goes up, you have per kilogram. When this one also go up, we also have it as per meter and per second. Please, everybody will speak for himself. But this way, if this minus crosses this, become plus. So we are going to have positive 2. Okay, that's good. Now, can we arrange them now? If to arrange them, I can possibly start with kilogram, right? So epsilon naught, because mass, we used to have ml t. So we are using this format before every other thing comes in. So that's why I want to use what? Mass first. So I'm going to have per kilogram. I'm going to have per kilogram. When I have per kilogram, the next thing that will come is my length, which is meter. And I have meter here, I have meter here. So you have to have m raised to power minus 3, because minus 2 minus 1 is minus 3. Then the next thing is seconds, s. Here, s is 2 plus 2, which is what? 4. Then what now remain? Ampere. So I can put my ampere here, raised to power 2. So this become the unit. This becomes the unit, okay? This becomes the unit of epsilon naught, or permittivity of free space. But what will be the dimension? The dimension, of this, using ml, t, and others. So we are going to have that this is m, capital M, raised to power minus 1. Yes, what is this? This is length. So it will be L raised to power minus 3. This is what? S time raised to power 4. And A, here is A now, which is ampere, the unit of current. So we put it like that. Some people will use I raised to power 2. It's still the same thing, because there's no other way you can break it down. That's just what it is. Okay. So this becomes the dimension of permittivity of a free space. I hope it is very clear. Please share this video and subscribe. Okay. Now let's do elastic constant. Elastic constant, from Hooke's law, force is directly proportional to the extension provided the elastic limit is not exceeded. So if Hooke's law say that force, from Hooke's law, this is number 2 question now. From Hooke's law, we have that force is directly proportional to extension, right? Now, which means F is equals to KE. Now we are looking for K. Our K will be equals to F over extension. Now, what will be the unit of F here? Which is kilogram as usual, meter per second square, all over meter. So meter, we cancel meter. Our K now becomes what? Kilogram per second square. Sure. So this becomes the unit of elastic constant. Elastic force constant. Now, what will be the dimension? The dimension will be equals to, what is dimension to this? Which is capital M. What is this? T raised to power minus 2. Okay, so that's it. That's actually how simple it is. Please share and subscribe, then turn on the notification button to get more of our videos. In other questions, we'll be working on applications of this. Thank you.